Friends, my name is G. Sandeep. Today we're going to discuss about multi-object optimization, power design and energy management strategy, fuel cell battery, electric vehicle. Abstract. Considering limit driving range and inconvenient energy, which range of inconvenient replacement way of battery electric vehicle, fuel cell, and electric vehicles are taken as promising way to meet their ability requirements for long distance, low carbon driving. However, due to the limitation of PFC power ability, a battery usually adopts as such supplementary limitations and power source fill gap between the requirement of driving and serviceability of FC. In consequence, energy management is essential and crucial of the between requirements driving of the severability FC. In consequences, energy management is essential and crucial to efficient and the following in favor self-optimization and based on purpose of less energy consumption and longer FC battery life can be accepted in FC and EV powertrain optimal hybridization degree. Introduction. The hybrid system has a substantial effort at the carbon neutral environment of protection promising has around the world transportations electrification and roadmaps for different vehicle types are proposed with varying propelling energy, zero emission battery electric vehicle, and PEV attracts great attention, especially in passenger vehicles sector, with acceptable driving range per charge and charging the schedule at home or workplace is is paid time. However, current battery capacity charging the technology is insufficient to meet the requirements of commercial vehicle and logistic vehicle, interstate buses and garbage trucks, which require a long range traveling and account for around 7% of global carbon emission. Thus, another green energy source is required to cover the 100 kilometers target range and refuel the energy source in minutes. Consequences and decarbonization in the transport sector compared to internal combustion engine ICE based on powertrain hydrogen chemicals battery based on fuel cell hybrid electric vehicle could realize longer drive range with lower energy consumption and zero carbon emission. FC stacks uses expensive proto exchange member generate a primary challenge and FC large scale commercial is cost which currently several times of ICE counterparts. Although although the FC an excellent energy density of meet and range requirements, the weak dynamic performance is power variation SCT. The requirement for power oriented energy source as supplementary source since frequent events power fluctuations has negative effect on FC service life. It is a wise to adopt a battery to evaluate peak power impulse by the outstanding dynamic performance of the battery. Furthermore, the chargeable battery of the capability of energy record which is missing FC keep in the density of FC significant superior to the battery of FC generally provides the average and the battery is responsible for extreme power variation climbing overtaking a launching has a auxiliary power source. On the other hand, opposite configuration to meet the driving power demand, the hybrid system can cover the high power events and at the same time keep the FC working in efficient zone and cell battery. EV prefers to use serial parallel powertrains structure to enable FC power electric machines directly or charge the battery when extra power is available. Thus, it's obviously the large battery involved and more improvement room is available. FC, but the expensive cost of electricity depends the ratio of maximum power capability of FC and battery, which is defined as a degree of hybridization of a hybrid powertrain, plays a key role of FC and EV overall performance. The study impact on vehicle mass ownership and energy efficiency. Offered optimization and dynamic performance of establishing a control model without a mention of cost since the frequent hyper discharge and charging current with the deteriorate the battery health. The concept design of powertrain specifications need comprehensive optimization considering system cost performance or service life period Furthermore, as a role batteries regulate the power flow in system, the power matching strategy is another key role in energy efficiency and dynamic performance. The objective of ordinary energy management strategy is determine the energy flow path between the different energy sources, properly minimize the quality fuel consumption. However, the performance of FC and battery degrades with the fuel aging. A competent of comparative EMS of FC and should not only work to traditional EMS. You can classify the model and optimize the rule based on optimization. Each of them is priority of compressors to achieve the target performance. Complex the timing and the difficulty to apply due to the due to the appliance of the practice and also requirements of prior acknowledge and rule. EMS is a relatively easy and generally based on the experience and the optimization algorithm and the climbing the level of experience and the methods of availability stage scientific are all important roles in RLEMS performs. And the regarding of RL development, extreme seeking process to the maximum power maximum efficiency of FC considering the FC aging sharing a similar idea proposed an online parameter identification model to tackle EMS uncertainties owing to performance drift of the power source. Davis proposed a rule based on two modes EMS for low power and high power events according to the total cost of ownership, which includes fuel consumption, FC, and battery lifetime degradation. Thank you.